Testing. Testing. I hear it on Zoom. Hear it? Testing, testing. So don't say anything stupid. Okay, excited. I already did. That's great. Yeah. So the clicker, just so you know, you can also point the laser. Yeah, I'm not gonna use that. But you want to click here and whatever, you just your best friend is also there. Yeah. If this has to be annoying. Perfect. Hi. Hi. How are you? Pleasure.
I'm gonna introduce him same. So I'm not. So it's gonna be a little different. So I'm going to just welcome everyone. And I'm actually gonna pass it to Daniel. Okay. Perfect. So it'll be a little bit longer. Okay. I was gonna say when you do, I'm gonna leave you with a mic. Just so I can catch some audio and I can use like little pieces of me talking throughout the.
Fine. Yes. Yeah.
Hang it right here off on the side.
Works. Fantastic.
All right, if everyone could grab their seats, we're about to get started. Awesome. Good afternoon, everyone. Oh, come on. We're not going to start. We're going to have a little bit of energy. Good afternoon, everyone. All right, awesome. Welcome to the second edition of the CARTA Generative AI series powered by Reekolect. Now, I asked this question last time and it was a resounding yes. Who here has been impacted by the use of AI in some way so far? Everyone in this room. And so that's why these conversations are very important, is so that we can explore and increase the public understanding of AI, especially generative AI, when it comes to the various disciplines, when it comes to communication, when it comes to design, when it comes to art. And so today we're going to continue those conversations with this series. And so we're going to be focusing on AI and the future of 3D printing, which would be a really cool conversation, which I'm looking forward to. And in fact, on behalf of the Dean's office, my name is Zion Seeley. I am the communication and the marketing manager for the office and for the college as well. Dean Trina couldn't be here with us today, but he wanted to send his regards, as well as thank you for joining us from the office of the Dean. Now, with us today is someone very special. We have actually the CEO and the founder of Reekolect, Mr. Daniel Sanchez, here with us. So I want to invite him up here to say a couple words before we get started.
Thank you. Thank you. Good afternoon to everyone. Again, my name is Daniel Sanchez, CEO and founder of Reekolect Corp. And with Reekolect, what we're striving to do here is develop a platform that allows you to preserve, share, and connect. And essentially what we want to be able to do is that in an era with AI and so much technology and advancement. We have social media, we can text, we can email, we can, again, video calls, anything we want, so much hyper connectivity, yet we feel that we're a little bit more disconnected than we should be. So again, we're striving to provide a platform where we can, again, be able to preserve your memories, as well as be able to connect with families and friends, and as well as share your experiences, leveraging innovative technology like AI. And though our mission is simple, it's definitely profound. We want to be able to revolutionize the way we connect and remember. And again, we're very thankful and honored and privileged to be able to power these lectures and these series, because again, we firmly believe and want to be advocates in encouraging not only the youth, but everyone to understand what AI is and take away the fear that we may have that a lot of Hollywood movies have put into us, and really understand that AI essentially can be a tool for us to be able to grow and evolve as humanity. So again, absolute pleasure to be here with everyone, and again, powering these lectures, and hope everyone does enjoy this. Thank you.
Thanks, Daniel. I don't know if you know what these guys are going to be doing in the future. I had the pleasure of having a discussion with Daniel on Friday. We had a very intense discussion about AI on a podcast. And I realized that what these guys are doing is they're going to be producing avatars. So you can meet your grandmother again, as it were. Totally fascinating. This is AI in practice. I wrote about these things in my book without really imagining whether they becoming a reality. But very soon, you're going to be able to speak to those you've known in the past, which is totally astonishing. Equally astonishing today, we've got Manuel Jiménez García, one of the most talented designers in the world, I think, and certainly the leader when it comes to designing and 3D fabrication. Manuel comes out of, he studied at the AADRL, and then went on to go and teach at the UCL Bartlett on the B-Pro program, where he was the director for a while. And now he's running Nagami in Avia, just outside Madrid in Spain. Some of you might have seen this last Art Basel, but a group from the Doctor of Design program, we were wandering through this exhibition and we were just blown away by this show. And we said, who the hell is that? And of course, we soon realized it was Nagami. And I should say no more. I keep bumping into Manuel all over the world. This time last year, we were in Kitzbühel in Austria at a super yacht designing conference. If you want to know why are they having a super yacht design conference in Kitzbühel, it's because they all like skiing. But anyway, it's fantastic to see Manuel here. I hope this is going to be a kind of the first of a continual collaboration in some way with Manuel, because his work is hugely invigorating, and 3D printing, I think, has been part of the school for some time. I don't know so many schools that have so many MakerBots. It was one of the reasons why I came to join FIU. I'd been working for NASA on 3D printer for the Moon and Mars, and came here. And of course, now the RDF lab is really taking off. Anyway, I'll say no more. You want to see this guy because this work is fabulous. Welcome, Manuel. Welcome.
Thank you. Thank you. I think this will make it, right? Everyone can hear it? Yes, all good? Perfect. Thank you, Neil, for the introduction, and thank you for the invitation. It's a real pleasure to be here and share, I think, more than the work, the journey that we've been going through for the last 9 years or so, although I would say probably longer, no? Since the digital started, no? And now we see the future of fabrication, the future of AI, the future of design, right? Back in the 2000s, I'm not sure if this is working, by the way. Back in the 2000s, it was very difficult to envision a day where we will be talking about the stuff that we're talking about today. So I'm gonna go through a few steps of this journey to try to conceptualize and understand how we can use the tools and the design methods that we have today. to basically fulfill a dream that perhaps started in the 2000s. That is, again, not working. Okay, that doesn't start well. The slides are empty. Magic. We were gonna talk about additive manufacturing, not subtracting images, but that's weird. Yeah, this is new. In the test, that didn't happen. No, it's definitely not like that. We can come back to the drawing board and just use that as a, I don't know, maybe we quit the presentation and start it again, or something. This is strange. You see it there. This, no, okay, no. Okay, guys, how are you? This is very strange. Maybe we close it and reopen it. Do you think we? In a world where we can talk to robots and create images with one sentence, PowerPoint is still not working. Close that one. No, but just maybe close it because it looks like broken. So close it and then open it again. Yeah. Okay. That looks good. Let's see. Okay, we can start a bit. I'm nervous. Oh, okay, images. We can see them everywhere. Good. Okay, so I'm gonna start back in the 2000 when Greg Lynn and then followed by others start to talk about digital architecture, right? And an architecture that could be organic, that could be controlled by other factors, that could be constantly evolving, right? Just 1 second. Okay. In this 25 years, a lot happened, right? And we evolved in parametric system, in digital design, in digital fabrication, etc. Up to the point that we have generated enough data on what it is, what we call digital architecture, that right now we can ask Runway to interpret what for it would be the embryological house by Greg Lynn made today. And it can already get a pretty much a good approximation on how it would look like. I would like to select a few kind of slices of the people that at least for my own research have been fundamental during these 25 years, and perhaps even longer. No? Perhaps it starts with rethinking the way we design with visionary designers like Joe Colombo or Luigi Colani, and how these forms and textures and this way of understanding design and architecture has evolved with the introduction of digital fabrication, robotics, automation, and 3D printing. With a special attention of these two people, Miguel Fisac and Jean Prouvé, who understand architecture differently. And they understood architecture as a product, and they wanted to take every single step in the design to production chain, right? So they were not only designing, but also conceiving those pieces as something that they could fabricate. They would set up factories for it. They would even be in charge of the logistics and the operations behind selling an object that could become a piece of architecture like this Maison Tropical. They were relying, though, on centralized manufacturing and long-range shipping, right? What if they would live today? No? What if today the architects can think about design about fabrication, and about delivery, about logistics, about production cost, about many aspects that architects didn't have to think before when we were working on the drawing board and then handling a set of drawings to a contractor, right? And we will do that through digital design. And this perhaps starts to open up a question on what would be the architecture, not of the future, but of today, with the tools that we have today. Today, we're living on a new industrial revolution, Industry 4.0, they call. What is architecture 4.0? And probably we still don't know it, or we're not putting it in practice, right? You see in this graph, what is the digitalization of different disciplines. In fact, it's not in this one, but construction and architecture is one of the least digitized industries, right after hunting and agriculture. I don't think they are taking into account agriculture in the East because it's highly digitized, and obviously it would not be fun to digitize hunting, right? At the same time, we urge to produce more and more housing to house an even growing or an ever-growing population, and our productivity is magically going down, right? That's the curve that you see, the pink one, right? Architecture and construction is still an incredibly long and wasteful process. So how can we rethink that? And perhaps we've been rethinking everything we do, right? With every tool that was enhanced at that time. Now we're talking a lot about AI and robots taking jobs, etc. What we consider the first robot, and this is how we frame it in the book I co-edited with Molly Claypool, Vicente Soler, and Gil Retzin, Robotic Building. The very first robot we had was the washing machine. Yeah, the washing machine avoided us to go to the river to wash clothes, right? Us, AutoCAD and other digital tools avoided us to draw by hand and to repeat the shape of a column over and over again. So how can we use the tools we have today to increase the level of the work that we do, to make design that we couldn't make before? And one of the most prominent examples, which is actually shocking, of highly digitized architecture or automated architecture was this company, Catera, right? So while we have robots in car factories to speed up production, to decrease production costs, to accelerate that process, the closest example of automated buildings is this one that looks exactly the same as any American house. So perhaps we didn't reconceptualize what architecture should look like if it's made from and for the tools that we have in hands today. In parallel, we've been going through 25 years of experimentation in universities and academic environments, research labs, and so on how to use robots and automation to make architecture not only faster and cheaper to build, but also make an architecture that was not possible to see and build before, right? And that's what we've been doing at the lab at the Bartlett for the last 10 or 15 years until we just closed it. But it's actually a labor, or it's a process on automating construction step by step. And in those steps, introducing something new, introducing something that you couldn't do before having automation. In fact, if we talked about 3D printing, and that will be the focus of the lecture today, we need to come back to 1939, yeah? When this guy invented a machine, obviously with the help of a human, to deposit material layer by layer, right? In construction scale already. What is the difference with what we are doing today with 3D printing concrete? Actually, not that much. Yeah? We are automating a process and designing objects that could take advantage of that automation, right? In fact, we see it also in other materials. You know, some of them very early examples on 3D printing by clay really look like something that we were doing before, right? So between pottery and 3D printing, there are, of course, many steps, but it's essentially an understanding of an object that can be built layer by layer, right? And so what would be the shift? I'm gonna talk here not only about design, but also about what it takes for 3D printing to really enter the markets, the design market and the construction market, like why we don't have, well, we actually have 3D printed buildings today, right, in concrete, and that's a different topic, perhaps for another lecture. But why we are not taking plastic 3D printing to buildings yet, right? And it's because we need to create an industry for it, right? So it's not only about design, but it's also about reconceptualizing the idea we work as designers and makers. Right? And that was the idea behind creating a design brand. And I'm calling it design brand before 3D printing for a reason that I will tap more into it later. Nagami, right? So Nagami aims to not only offer a way of utilizing or using the advantages of 3D printing for personalization, for creating forms and shapes that were not possible before, for working with a material that is sustainable with recycled plastics, for giving a different speed to construction, right? But also to get all that and bring it to a real market. Yeah? And our journey for the last few years have been not only about finding the right process, the right design, the right printing quality or technology, but also how this could become real. And to become real, you should be able to sell it and people should be able to buy it, right? And we will tap into that a little bit later. So we started with trying to materialize what was yet unbuildable and printable, right? So pushing the limits not only of 3D printing, but also creating objects that would not be achieved otherwise, right? So these 4 chairs that we used to launch the company in 2018, designed by Daniel Widrick, Ross Lovegrove, and Zaha Hadid architects, were not only impossible to materialize with traditional manufacturing, but were actually impossible to achieve also through 3D printing. So how can we push the limits of the technology to create something that was impossible to make before? And we use the experience together with these architects and designers to push the limit of the technology, to really develop tools, both in software and hardware, that would allow us to create these organic shapes, for example, to introduce all the materials mixed with 3D printed objects, and in fact to create a whole ecosystem on how to design from and for 3D printing. And I really think that Ross explains this much better than me, so I'm gonna let him talk.
When you're faced with something like that, remember these are forms that in the past maybe you could draw, but you simply couldn't make, and unless you had somebody spending weeks doing it. So I think we shouldn't underestimate the freedom that contemporary technologies give the fertile mind. But you need the kind of you need both, you know, you need the design mind which kind of build things up, and then you need this other algorithmic mind, you know, the one that can kind of step in and understand the complexity of mathematics. You're building in thin air without a mold. and I'd like to bring in new species, new things that people have never seen before.
Now is that moment, right? I think Ross explains it fantastically well. It's really about design and technology together, right? So you need to think from a design perspective and from a technology perspective to create something that is making the best use of this tool, or perhaps opening up to new tools to be developed. No, like that's what happened with the Zaha Hadid Architects chairs that we built before. This is printed in a transparent body for them be scanned and then printed over in a different direction. So we were really creating bits and pieces of software that would allow us to materialize these chairs. And in here, I think Patrick will talk about it.
Well, I think these techniques are part of the computational revolution in civilization. And what I like in particular about 3D printing, it seems to be less constrained, particularly with respect to intricacy and three-dimensional complexity. And what it adds to this is versatility and variation. So I think in our designs for Nagami, we're trying to show that potential. There is various layers of printing and lines drawn down the surface are printed over lines which are more normal, the usual contour lines which are running up from the bottom up. And I think it's great that Nagami is bringing characters like us and Ross and Daniel into this, and I'm sure there will be others lining up to join.
Well, so for developing these 4 chairs that we did back in the days in 2018, we had to develop a few special tools. One is to get rid of this idea of 3D printing as being a horizontal slicing, and really take advantage of all the axes of the robot, right? How can we start printing with a different choreography, tilting the extruder to achieve non-parallel lines that would allow us to have different forms in the object, right? So break up with that idea of horizontality. How we can push the maximum dimensions and the movement of this robot to create an object that wouldn't be conceivable otherwise. And how can we push that further to basically balance up gravity, right? So in this case, we have 2 robots. Here you see the video. 2 robots working in multi-move. One is moving the molds, and the other one is moving the extruder. So essentially, you can print way deeper angles than with conventional methods. No? But the most important part for us, and that was a key milestone in our journey, was to make all these accessible. Those 4 chairs were still developed as a cornerstone, as an art piece, 20,000 euros each. But that really forced us to develop the technology, to then be applying that technology in way more accessible objects. So the goal was actually not to create only art pieces, but to compete in a real market for design chairs, such as with these ones that are just about 500 euros. They are a bit more expensive in America, yeah? So that you know. I'm sorry. Shipping and all that. So we started developing a catalog of products, from chairs to vases to lamps, etc. Really exploring different surface qualities that we can achieve that are actually extremely connected to this technique, that are not present in more traditional manufacturing methods. That's my dog. That's the most beautiful part of the presentation, of course. Not 3D printed. Having different textures, from micro textures to then organic kind of displacement of the shape that conforms the chair. to robots working collaboratively. In this case, this is beer draft, and one robot is printing the object, and the other robot is mechanizing the parts where you would get the rest of the mechanical parts of the beer draft. But in reality, I mean, those pictures are great and beautiful, and they look amazing in Instagram, but this is our everyday. So 3D printing is really, really, really far from the magic of the print button, right? And especially at this scale, perhaps at the small scale, it's true, and 3D printing is a service. At a large scale, it's not. You really need to learn what are not only the opportunities of 3D printing, but also the restrictions. Because those restrictions will make, first of all, the stuff that you design possible or impossible, or even worse, close to impossible, meaning too expensive to make, and therefore too difficult to sell, and therefore it's not gonna make an impact in a real market. So for an object pretty difficult to build, like this one, this will be kind of middle ground, borderline. We required 15 prototypes, almost 500 kilos of plastic, 300 printing hours, and 3 months of rationalization of engineering, right? So even if the promise of 3D printing is, oh yeah, we can create every piece different, these are the implications of making every piece different. And I'm gonna explain that in a bit more detail in the following slides. But to avoid this piece to cost 25K, we need to make sacrifices on the design so that this actually doesn't require so many prototypes, or obviously make a lot of them so we can offset that initial cost. That brings us to a more conceptual question on where we think that 3D printing kind of navigates within the domain of design on an architecture. And 3D printing has normally been associated with parametricism, right? We can make every single piece different. And at that scale, might be right, at the scale of the object. At a large scale, it really isn't. Because that means that these printing errors, these headaches, will multiply by the number of pieces. And therefore, prototyping time will be way longer than production time. And this is really the opposite of mass manufacturing, right? Of the Henry Ford assembly chain. That is what brought personal vehicles to our reality. Why? Because it amplified the market by reducing manufacturing costs. By one sacrifice, every single car has to be the same, so you can fit in that production line. Henry Ford used to say it can be on any color as long as it's black. So you couldn't even choose the color, right? I mean, black is a good color, though. You guys all know it if you are studying architecture. So what happens with Fordism? That there is a small time prototyping and setting up the production chain, and then every object that comes out of that chain is a success, right? And that makes it way more affordable, and therefore, you can access 99% of the market. If we keep on doing everything special, everything iconic, every single piece different, we're still navigating in the 1% of the possible market of architecture, right? In fact, architecture is probably one of the very few professions where we only want to work in a 1% of what is accessible for us, no? So how can we use these tools to change that balance, right? And as we were saying before, 3D printing perhaps is actually close to parametricism at a small scale. Larger scale 3D printing situates itself in kind of in the middle, right? So it opens up a new question. What is the real market of architecture and design after we use 3D printing for real? No? What is the sweet spot for 3D printing in the domain of architecture? And for that, I'm gonna navigate through a few projects that are aiming to find that balance, right? That are trying to create something new, but without having this image constantly in your factory, right? And one of them is trivializing errors. If you guys have 3D printed something, that probably most of you have, you probably went through that night when you left the machine printing 30-hour object, and then at the very end, it broke, right? So if that happens in an industrial level, we lose a lot of money and time, right? So one of the possible approaches is serializing errors. In these projects that you see here, the very first one we started with the lab at the Bartlett, we are prototyping only one line fragment. So the whole object is a combination of that line fragment to create a continuous line that will be printable by the robot. However, if we've tested that line in every single position, every single rotation, we know that the totality of the object will be printable. And that is what we are doing with the voxel chair a little bit later in 2017. That's actually how we started with Nagami. So just to give an idea, and I think I have a few more slides about this, but that was the very first garage that we had in Nagami. Actually, probably the picture couldn't be taken from a little bit farther, because that was about it, like just a few square meters, right? And we created a software that would arrange this line that would be previously prototyped into creating a 2.4 kilometer long continuous line that we would know will be printable with a robot. In fact, that chair took 3 weeks to print with a robot completely autonomous. And we knew, because we prototyped that line fragment before, that every single part of that object will be printed successfully, right? And this is, for us, a very interesting milestone in the use of this technology. This chair is, as many of you already appreciate, it is a version of the Panton chair. The Panton chair is the world's first plastic molded chair. And this is really taking that shape and making a new version of how we could conceive an object like that with a technology that didn't exist before, right? That really doesn't operate with surfaces and molding and demolding anymore, but it operates in volumes, right? And in fact, we created, I think it's like around 24 different versions of this chair, programmed within that software that we built. Today, and we didn't have AI back then, but we're still better than AI. So if you ask DALI to create the evolution of that chair with the current technology, this is what would show, no? Which I really don't think they're as beautiful as the voxel chair. I selected a few of them, and this is voxel chair inspired in theory, and this is blends with the original voxel chair. So the good news is that the AI is still not there, right? So it's still the original voxel chair. I don't know what you guys think, but it's still the original voxel chair is better. However, these tools will evolve, and as the software that we were building will be learning those steps to connect those line fragments efficiently, this would really start to understand what is the intrinsic functioning of that voxel to create an object. This is what the AI thinks that will be taking this strategy into a house, right? Still, also, not the ideal voxel chair house, right? Not bad, but not great. Another step that is incredibly key for Nagami is to really change the role of the designer and the role of the maker into becoming an industry, right? And that has been incredibly challenging, also because 3D printing, at least at this scale, is yet not an industry. There are no industry examples of 3D printing plastic with robots. So this is how we started as the very first garage. Then we moved to a 3 robot facility in 2019. then later on to 5 robots during COVID. And now we just got another 16. So we have 21 robots 3D printing, hopefully very soon 24 hours. Right now they are printing around 12. No? But that really changes the game. First, you need to automate the process much more. Like this has automatic feeding and all the kind of technological advances that would make this to work way smoothly, right? But also this allows you to take all the projects that you couldn't access before. Like when Dior asked us to dress their shops for the new collection, that was actually, I mean, when a fashion brand launches a collection, they normally do a branding experience in all their shops for 6 months, and then they throw it away, right? So we were basically jumping in to offer a design personalized for them, and then 6 months later, take the plastic and recycle it, right? But back in the days, we couldn't access more shops than 3, right? Today, we can take on way larger projects. Like this one, which is 25 meter long ceiling in CaixaForum, in the Calatrava building in Valencia. But to really make it efficient, we need to always search for the right equilibrium between humans and robots. And that is continuously changing, right? So with Elon Musk robots now, it's probably gonna start leaning more towards robots, right? But 3D printing, again, is not yet a push of a button. And sometimes it requires human intervention, right? So how can you make a business plan that makes you scale that production efficiently, right? And we made this growth based on a project that was clearly just designed for 3D printing. So we couldn't do this project with any other technology. That was 80,000 seats for Santiago Bernabeu Stadium, right? Not the seats for the new stadium. We were taking the old seats and then transforming them into chairs, bar stools, etc., so that fans could actually take one home, right? So, and we made the entire kind of process, and then we did the machine learning for classifying all the seats. So actually, you can buy the seat where you've been sitting for decades and decades. And it was a total mess. It was very difficult. Like, think about it. It's 80,000 pieces, right? So no one has ever printed 80,000 pieces. So we basically jumped to the pool and said, well, we can take it. And we encountered millions of problems on the way. But we thought that 3D printing was the tool that could make this possible, that the robot wouldn't mind to print one piece right now and then a piece completely different later. No, the robot doesn't. But the guy who is managing it does, right? And that really leads to a scaling up on production costs. So we decided in a second phase to really fine-tune this thin line in between personalization, in between pushing 3D printing to the limit and mass manufacturing. No? And that's where we think this is becoming incredibly interesting, right? So what is the right edition, right? Is 3D printing great to make every single piece different? Is 3D printing great to compete with mass manufacturing? And perhaps the answer is still not there, and it's not A or B, right? And we have a further question, which is, should we work, or is 3D printing more efficient in products or in projects, right? So now we're in that process of analyzing how much would it take to create a new product or to create a new project. And we're launching a catalog, but it's a flexible catalog. That's, again, something that you couldn't do with another technology. No? So it's a catalog of pieces that you can yet personalize, but within a range, and that you can show to someone and say, well, I actually really like that chair, but I'm building a theater, like in this case, in Ibiza. I'm building a theater. I need only 250 chairs, then 250 stools, 100 tables of this type, 100 of this other. Obviously, no one could do that, right? There is no technology that would do that at an affordable price, right? We can create a completely new object personalized for you for a small edition, right? And that is starting to become very interesting. No? It's editions that are too large for a 5 robots manufacturing that we had before, but it's still too short to make plastic molding, for example, more efficient. No? And in fact, now we are automating a little bit more of this process. So then another client, Porsche, came and saw the chair, and they wanted a version of that chair, which of course we modeled. AI is still not making great design in there, but a bar that would go with it, right? And so we just, this took literally a matter of hours. So we created an AI image trained by our wall panels, and then finally printed the following week. So the entire project was literally 2.5 weeks long, right? Creating 250 chairs of a completely new model just made for them, and a bar trained by our patterns. And we're actually now taking this catalog into also automating the placement of the objects in different environments, right? So you can literally take the model and bring in new pieces from the Nagami catalog and even personalize them further, right? But back to one of the main questions that have been with us from the very beginning is why this would make sense, why we should 3D print design and architecture. Obviously, if you guys know a little bit of 3D printing, and perhaps this is common knowledge already, but again, 3D printing can bring you one opportunity, which is with one machine, you can create multiple variations of a product, right? So the machine would mind to, like in this case, change in a matter of hours from building vases and chairs and wall panels to print PPE to fight against COVID, to donate hospitals. And further on, we're perhaps just scratching the surface of the potential of 3D printing, but it's a technology that is completely paired to distributed manufacturing, right? And we're already talking to different partners to start avoiding long-range shipping, to make sure that the printing quality is the same because the machines are compatible, and really start creating a map on 3D printing hubs at a large scale that if you are building something around the corner, it doesn't have to come to Madrid, right? And at the same time, it's working, or it's allowing us to work with what we call an unfortunately unlimited material source, plastic, right? And plastic has always been fundamental. So plastic made like the great designers of all times, like Dieter Rams, to really reconceptualize objects that we use every day. And it even disrupted locomotion with Pierluigi Colani or Raymond Loewy, and even architecture, right? You know, in the 60s and 70s, we were imagining living in plastic bubbles, like creating pieces of furniture that were coming from the walls, right? With the invention of fiber-reinforced plastic, architecture was also changing. However, in the 90s, we were aware that plastic will be with us forever. And that is what really stopped using this material for architecture. In fact, right now there is 8 times more weight in the planet in plastic than in people. So each of us have a plastic footprint of 650 kilos, yeah? Which is pretty insane. So what if we could use distributed manufacturing to really increase the speed at that we use for recycling this material, right? If this really starts entering the domain of architecture and construction, that is where the real mass of material comes into play, right? Not with fashion, not with the small household items, with architectural elements, right? And that's something that we're investigating in larger scale projects that are really trying to pursue this idea of modular 3D printing, no? Modular, but in brackets, Because so if you coin that term at the beginning, it doesn't make any sense, no? Like why 3D printing modular? You can make every piece different. But actually there are spaces in which 3D printing is incredibly optimal, right? For example, if you take a single building that has a huge collection of panels, right? But those panels are not going to be a product in the market, right? They are going to be just part of that single architectural piece. So we're taking this concept of modular 3D printing at a micro level and pushing it into larger levels, right? So how can we create a piece that we can alter the height of it? We can have different modules. We can alternate or alter the type of the piece that we build. But we always keep a connection strategy, right? So it's semi-modular, semi-flexible. We're exploring that into a project that I can't show anymore right now, but this is a massive 3D printing project. And hopefully very soon, also in a housing project, where the concept of modularity is really changing. So modularity doesn't mean anymore the exact same objects, but it means the same strategy. It means a connection that we know between one piece or another, but the pieces are still customizable. Like still someone can say, I want a shelf here, or I want a higher roof, or I want a seating area, right? So modular architecture really start to be reconceptualized, no? And for that, we need to also be able to print larger and larger pieces, right? And as I mentioned before, we started with chairs. This is an incredibly architectural example on researching something new. Like most of the seminar architects have done seminar chairs just for testing new ideas that they would then rethink in an architectural scale. And that's how we were doing it back in 2019. And with a process that would take us to print up to 3.5 meter tall in just 48 hours, right? Like we use for this piece design for Rosloff Grove. Or how can we grow larger, right? This is a sculpture with Ecological Studio that reaches 12 meters. So how can we make large pieces that still would connect with one another to create a way more vertical piece, right? Or this one with Nicolo Casas, who used to teach here, right? With Nicolo Casas and Parley for the Oceans, right? Again, 3.5 meters. And also start checking different constraints that we learn in the process that we start incorporating into our notebook of possible problems that we have. No? Printing something flat, actually incredibly difficult. It's way more difficult to print a box than to print an incredibly organic shape because there's an uneven distribution of heat along the surface, and that produces deformation. So you need to end up making smaller pieces, right? If you want to do an incredibly flat facade, right? Or you need to reinforce those parts, right? So actually printing flat, again, needs more layers, needs more material than printing something organic. And we start to control that and parametricize it, right? And the same surface can be filled with more or less material in the same print. For example, to make this pavilion, we were not only optimizing for structural optimization, as you see here, but also for printability optimization. No? So we have new terms coming into play that come from your experience developing these tools and testing them out. No? How the way you are folding the lines start to make more rigid a part of the structure while keeping some of the flexibility of the material. This is how we test chairs. Sometimes if we don't have time to send to laboratory, this is 250 kilos in flexion. And that's the same concept we apply to larger architectural pieces, as you see here, no? For this pavilion that we built in the Netherlands, right? What is the most efficient way of dividing this into different pieces? What would be the way to install them and make them working as a whole, right? So this is an entire process that becomes part of our catalog of possible 3D printing solutions to rethink architectural elements, right? Connections, right? If you are printing, now we're printing a lot of facade or interior panels, right? And you can actually hide the connections because the machine can print concave and convex shapes at the same time, something that you couldn't do with plastic molding, right? So how can this be taken forward into create fully continuous surfaces like that 9-meter interior panel? Different finishes, right? Different ways of working with lighting. As we see here, this is a Cartier shop in Milan. Different ways of connecting panels, right? And different ways of understanding concepts coming from collaborators. This is Spanish brand. Only like purely based on recycled materials. They wanted to recreate the feeling that you will have having a glacier, melting, cracking. We started having discussions with I think that's taking too long, so I show you the pictures directly. That's also in Madrid. So that brings us to, well, kind of almost the last chapter, that is, again, the opportunities that we have to reimagine. Perhaps it's not reimagining architecture, but reimagine building elements, right? And which ones are worth to redesign and which ones don't. So all of these experiments that we've been doing in multiple scales kind of meet together into an entirely 3D printed building, which is a pavilion that is currently in process, where we're exhibiting, for example, this non-planar slicing that we did with the Saha chairs, right? And that allows us to cut this building into pizza slides. What would be the best way to enter such a building? And in this case, it's aligning it with a printing bed, with that flat surface that we always need. So we're really reconceptualizing the way we treat a structure, right? So rather than multiple layers, we have a volume that becomes denser or lighter. That becomes something that is incredibly or fully controllable in different parts of the object, right? How can we connect pieces together? Like in this case, for this connection direction, we're conceiving the pieces, including the facade, as building blocks. This is almost like a Lego for grown-ups, so that you can actually slide one into another with a male-female connection. This is a further evolution where we are detaching the facade and then making it again with a different material. How can we make objects that move, right? Like perhaps those parts of architecture that we never think of, like doors, right? Or what you have in the image on the right is a door handle, right?
Our approach to waste, both human and artificial, has a profound impact on the future of humanity and our planet. 1/3 of the world's population still lives without basic and safe access to sanitation, while plastic keeps on filling our oceans and our landfills.
The 3D printed toilet front has been an incredible challenge for us. It is printed out of 100% recycled materials. Working with...
I'm not going to play it further because it's also me talking and it's embarrassing. And obviously, as you can notice, I didn't sleep the night before. So this is, again, I really think, I've been looking, but I really think this is the world's first plastic 3D printed door. And if not, it's definitely the world's first plastic 3D printed door in Avila. Yeah, that's my hometown. So yeah, again, introducing channels, right, for other pieces that are not printed, right, or off-the-shelf products, such as, you know, the toilet itself. No? How can we make a smooth process in between the parts that are printed and the parts that probably shouldn't be printed or shouldn't be printed yet? Yeah? And as I was saying before, this is all these experiences feeding into this one project, but it's also feeding into a new part of the company that is fully dedicated to AI, right? Where we are learning from these processes, learning from the mistakes and the opportunities, from the styles, from the finishes, right? From the way we treat form and texture, and start training models you probably have done this experiment, or everyone has, like design this in a Saha style or in a Cobb Himmelblau style. No? So now these models know about Nagami and can actually transform a sketch into a Nagami style 3D printed chair. No? And can, of course, start giving more options for these objects and immediately make them 3D, right? So this is accelerating, obviously, the communication with the design team and with the clients, where we are not just shooting a mid-journey image to a client and then the client getting really disappointed when you develop the project and start realizing that much of that stuff is actually not possible, right? And then the client keeps on saying, but you sent me that image. It's like, well, no, but it was the AI. And because I was really tired of having that discussion, now these models are starting to invent or create based on what is possible in our technology. And not only that, but also what is our style. In here, it went a little bit off. Like to print that first lamp is actually pretty challenging, right? But this is perfectly possible. And each of these images is based on some of the projects that I've been showing you before. No? So it's learning the style, it's learning the texture. Like you can even see the printed lines, right? You can almost recognize some of the previous projects that we've printed in these images, right? And we're taking this into larger projects, such as this theater, this exhibition space, right? So different kind of experiments that are giving us this security that what we are using AI for is actually useful in the process, and it's not just a board full of ideas, right? So some crazier stuff. This is a bar I'm really pushing to build in Madrid, again, based on some of our previous projects. Pavilions, right? Kind of, they really have this Nagami kind of atmosphere. This is still really rudimentary, and this is a project that we're really starting now to take on way more seriously. This is the facade of our showroom in Madrid. So if any of you guys come to Madrid, we have a showroom in the center. It's amazing because you have great places for food right there. Yeah, so I highly recommend it. Or even yacht interiors or Christmas trees. This was actually funny enough. I've been showing all these like pavilions and chairs and design and facades. The most successful post last year was the freaking Christmas tree. So yeah, perhaps the business is actually in Christmas trees. So with that, I'm gonna leave you with a video of the factory of the upper level, which is the laboratory. This is just to push you to come visit us in the next street to Madrid. Good, that's it. Very good. One hour.
Well, that was extraordinary. Thank you. Thank you, Manuel. I want to open up some questions. I just want to make a couple of observations myself. One is that what I was talking about last week, what we're going to see is not AI on its own, but AI incorporated in other areas. I was talking about Demis Hassabis, who got a Nobel Prize for chemistry. He's an AI guy working in chemistry. Here we see how AI is feeding into the world of 3D printing. But the other comment I made last week was really what we have to do as a profession, as a discipline, is not to design a building, but to design the very future of what we're doing. And I think what we saw here, aside from the astonishing products themselves that are extremely beautiful, was an architectural mind at work in trying to get a system to work and to produce something totally novel, a form of industry that didn't exist before, but it takes a kind of architectural imagination to get there. So absolutely astonishing, very invigorating work. Let's open up to questions from the audience. Pavleen?
I want to start with some praises and comments. I mean, the work is incredible. I'm a fan. I know many others who have not been familiar with your work are a fan now. They're going to be just following you. What is interesting, I think, in your work is also the collaborations that happened over the years, whether it's with Ross, Daniel Widrick, from institutions to offices, everybody I can see there has collaborated. So I wondered, like, what is the next now for Nagami? Like when you are venturing into the whole, this field of AI. And it's interesting you mentioned something about Nagami style. It is there because the catalog of work that's there, it's totally something that one could just put it in the AI and start to generate images, and what we do with Zaha's office and renderings. But are we there yet with the 3D printable kind of forms, or is there still an intervention that you have to do as part of your studio to really make it 3D printable? Because the striations that it's still producing, it's still kind of taking, I'm sure your office is thinking, or there is a lot of work that goes into it. So I want to know more about that. And then I have a second question, completely unrelated. What do you think holds for us in architecture schools and at the level where teaching undergraduate programs and all? What knowledge barriers do you think can be really lowered to bring about more people and more Nagami designers and more setup of offices which are practicing purely robotic 3D printing? Because 3D printing otherwise is quite adaptable. So these two questions.
Good two questions. Okay, I'm gonna try to start from the beginning because actually your next question is quite complex. I'm gonna first say, completely honest, what's next for Nagami is actually making way more efficient. Yeah, so it's been a playground for designers, including myself. And we've been making lots of projects that sometimes bring money, sometimes they don't, etc. If you don't make money, you can't bring progress forward, right? So you can't create something new. You can't save the world. That's not our aim. But at least we need to, if we want to introduce this into the real market of design and architecture, we need to become much more organized, much more efficient, right? And that's where AI is coming in, but not only in what we're seeing here, but also in business. Like we're using lots of tools that help us understand our company better, extract data. Like, we used to not measure anything. Right? Now I know which robot was printing that, who managed it, how long it took to put the piece, to take it out, what was the material that we're using. So I am fully conscious of the time and money that we're actually wasting in the company. So I know that a robot in average is working 10 hours and should be 15. So where is the leak? No? So that is actually our current more urgent stage, which not really fun for a designer, but it's actually a very interesting project, right? That on one hand. On the more creative part, this is still a sketch, right? So it's very rudimentary. Of course, I wanted to show the mesh that you are taking in 3D, so that you see the steps that are missing, right? And right now we take that mesh and then we work over it, and then we keep on getting into our software and generate the robot program and testing and so on. But basically attacking, one question at a time, perhaps will bring us to a fully automated workflow in which we're not just repeating what we're doing and training models with Nagami's work, but we're actually using our time to create more work and more variations, to push that model to unexplored territories, right? So I really think that AI will be a good companion on, to be honest, sometimes I love modeling in Maya or whatever, or programming, but sometimes I just don't have time for it. And I wish I could just be having a creative conversation with someone, make a few sketches, and then keep on curating what would look better, what would be more groundbreaking, right? And we're reaching that moment with AI. So for us, that's incredible. It's basically taking most of the boring parts of the process, yeah, and try to automate it, right? So that's kind of the next step for Nagami. A part of now, we're also trying to push this distributed manufacturing, as I've been showing before, right? So landing in Miami or in the States, right? Landing in other geographies is also really important, and hopefully will come in the next few years. The second question, remind me.
It's more related to what role do the educational institutes, especially architectural education, play in creating the next generation of architects who could, or designers who are specialized in bringing in robotic 3D printing more strongly?
So, I mean, in there, if you asked me that question 10 years ago, or maybe even 5 years ago, I would say, wow, we need to, encourage our students to become entrepreneurs and create their own companies. And these are brilliant ideas. They can't just stay in an academic environment or just die or be bought by Microsoft. Now I would probably answer it differently. Not everyone has to be an entrepreneur. This is not to avoid competition. Yeah. So I still encourage it. But I think experiences like these ones and many others that we have around are teaching us different pathways that are accessible through the training that we have as architects. And not only architecture as a design profession, right? But there are many things that, this company is coming from architecture purely. Also because only an architect would think, well, let's build a plastic extruder. It's all right. I'm sure I will manage. Architects, like one of the values that we normally don't take so much into account in architecture is naivety. Like architects are naive enough to say, oh, have you ever done a hospital? No, but I'm an architect, I will do it. And you have to learn. Have you ever created a plastic extruder, founded a company? No. So that really comes from it. So I think if I will have to create a new school, I will really rethink on or start classifying the stuff that is about the basics, learn how to design what the building is and so on, and really understand the potential of architecture to become many things, and would probably just focus on the part that is not AI teachable. For example, we were coming into this school and it's a Bernard Schumi building, It's a, yeah, but many of the students today don't even know who Bernard Schumi was, right? Like those kind of stuffs, like the one that will be best at designing with AI will not be the best AI guy, will be the best designer, that is just adapting to a new tool. And it has always been like that, right? Like, I don't know, my colleague Ross, right? Like Ross Lovegrove you see his drawings and it's amazing. And you see that he's just an incredible designer. You feed an AI model with that drawing and it makes exactly what he wants, right? But it's because he's a good designer, not because he's good at AI, right? So, yeah. Eric.
Yeah. Manuel, to put it in football parlance, that is soccer parlance, eres un crack. I think it's extraordinary. Thank you for bringing this talk. And, I was actually at the NE conference in New York in 2000, where Greg Lynn presented the embryological house problem, let's say. The way he was conceiving of moving that forward, even though it was so far ahead and so far behind, was recognizing, like you did, that the architecture is so far behind regarding other industries. And he was trying to collaborate with BMW to be able to figure out how to fold the metal, those carcasses. And I was wondering if you have in mind, or have you collaborated with other industries actively that may expand what you're trying to do? Because on the other hand, I think it's so unique what you're trying to do, just understanding the constraints of the very fabric of making, and with that creating new architectural problems and solutions. Yeah. Problems in the sense of like the opening, all of that stuff that you're showing, how to enter a space produced by, showing the guts of the wall. So extraordinary. But are you collaborating with possibly other industries outside?
Actually, that's a very good question, because I did forget to answer a part of her question before. What is important about Nagami, and that's why I say, well, Nagami is style, or let's say Nagami is a design brand, right? And that's why at the beginning of the lecture, I didn't really mention so much of 3D printing. So it is focusing on 3D printing just because we wanted to create something groundbreaking and impossible to materialize otherwise. But in 5 years from now, no one will talk about 3D printing, as no one will talk about AI, because it will be already there. I mean, no one talks about plastic molding today, no? You don't look at that and say, oh, it's so cool, it's plastic molded, right? You don't do that, no? So I think 3D printing for us is a vehicle. And as such, it's perfectly combinable with many other vehicles. And actually, I have a few projects now for furniture to combine with other materials that are, I mean, obviously a 3D printed sofa is not comfortable, right? But also in facade systems with integrations and connections that are, of course, not printed. Post-production of some of the panels and the pieces that we do, for example, like, how do you call it, sandsuiting? Sandsuiting? Cuando echas arena, baños de arena. Sandblasting and other kind of processes, metal plating, and so on, but also making hybrids, right? Making hybrids not necessarily only with digital techniques. I remember when I was working in kind of, let's call it classical or commercial architecture. That the guy you would learn more from was actually the construction worker that is there applying a technique that he made himself or that he learned from his father, right? Many times there's someone coming in the factory that challenges our process and say, well, actually you would make this like this, right? It will be more efficient. And I have a few projects that I haven't shown today, both in products and in more architectural scale, that are actually combining those two. One is actually about folding metal, metal bent and 3D printed parts. Another one, which is actually for Miami, and it's also a wall, right? A large wall for a facade. And that's mixing, is together with an artist, and is mixing parts that are painted, parts that are printed, parts that are printed and painting, and then some painting parts that have printing on top, right? So I really think we are just at the beginning, and we've been too purist, just because, to be really honest, because I couldn't make anything else, you know, because my workshop is so small that is just already, you know, at maximum capacity, just fulfilling what we need to for the pieces that we print, right? But I really think there's a huge plethora of possibilities that we will be seeing not only from the work on Nagami, but also other companies in the next few years when we stop being so purist about 3D printing. Yeah.
Plastic do you use?
Sorry?
How much recycling of plastic do you use?
100%.
100%?
Yeah. So the stuff, well, we have several types of plastic. The main one is recycled PETG, mainly coming from hospital waste. Yeah. Although we have other sources, like we also have like plastic coming from the ocean and all that. But now we're initiating a set of materials to work with that combine also organic waste. So now we have recycled plastic combined with coffee grain, with oyster shells, with timber wood, with cork. And each of them have like one finish, one kind of a structural behavior. We have one that is flexible. Like the world of plastic is just growing at the speed that I was really never imagining. So we're on one hand working on that, and then also with biodegradable materials. So sometimes it's mixed with recycled plastic, sometimes mixed with biodegradable. And then also we have full circularity in-house, meaning we grain, how do you say, trituradora? We grain the material from prototypes, etc. So anything failing, it just goes to the first floor, and in the first floor it becomes flakes. And sometimes we use the flakes directly, or sometimes we send to palletize, and then it comes and we reutilize. The material loses only 1% of the properties every time you reuse it.
So building on a little bit on what you had just talked about, we've seen different applications, some of them being interior and then exterior, and then some for short, and then what seems like very long-term projects as well.
Yep.
So speaking towards the experimentation that you've done on these different plastics, is there anything that stands out materiality-wise that seems to be like the best for long-term solutions, or for short-term solutions, or for things that maybe we use shortly and then we can throw them away, they might degrade, you know, and become biologically broken down? What are some of the materials, like, I guess, the highlights?
Definitely. Actually, like now when we have a conversation about a new project, like first we ask for the requirements. What is it going to be? Is it going to be outdoor, indoor? Is it going to be in France, or is it going to be in the States? Fire regulations, for example, right? And fire, like, it's always performance and sustainability. And that's the balance. So the question was actually really well oriented. For example, most of the chairs, the facade panels, and so on, we're building them with fiberglass reinforcement or with carbon fiber reinforcement, right? Because the behavior is way more stable, right? So if something happens, it will never crack. And the finish is different. So you already have that conversation from the beginning. Our plastic is already M1, so and it works okay in terms of fire for most of the applications as well. But it really depends on if you want something shiny, matte, transparent. No, so it's always a balancing between the performance that you need and the surface quality that you're looking for, right?
Hello. Yeah. So the question is, well, fantastic work. It makes me think that a lot of the work, it's about finality. You're 3D printing something that is in and of itself an object as a final thing. But I'm curious if, and this triggered the Bernabeu project is an interesting example of working with something that's already there and you're adapting to it. But in the same way, have you experimented with this level of work, but as a step towards something else? And by that, I mean, for example, form work, which is for concrete, or lost wax for casting, whereas 3D printing can be a vehicle that allows you to do really sophisticated things, not as a final thing, but as a step towards something else.
Yes, definitely that's an avenue to explore. And we've done quite a bit of experimentation there, but more from the lab, from the research lab in UCL, that sometimes we brought to Nagami. Like, for example, the form work, which is, for me, incredibly interesting. I did a workshop together with Anton Garcia Abril in MIT for using, again, plastic as a thin cell, right? There's Benjamin Dillenburger is doing also very successful research in ETH about that. And then cast, no? And then you can actually leave it as lost form work or not. And there are many discussions that come after that are more about, you know, the quality, the surface, and what you are looking for in the architecture, right? There are multiple problems, like, for example, the hydrostatic pressure. Like when you use this work, plastic as form work, you need to be casting as you are building it almost, because otherwise the hydrostatic pressure will basically destroy the bottom, right? That's, for us, incredibly interesting. To be honest, I haven't really pushed that forward. We were printing, you know, also clay and even plaster. Like, I really don't think there's any other example of printing plastic, basically, plaster, basically because it doesn't make any sense. So I was crazy enough to do it. I don't know why, never tried, right? So that kind of experimentation will definitely be reincorporated in the company when I manage to close the next financial round and then have a lab dedicated to experimentation. Right now, it's just, we experiment as we build. Every project for us is a necessary research and development push, right? Because otherwise we don't finish the project. But we don't have that part of the lab that I miss to bring in new avenues, but they will definitely come back. Hopefully I close the financial round next month, so ask me in a few months. If I don't answer, it's because I'm depressed because I didn't close it.
Yep. We need to wrap up. I just want to finish with one question from Manuel. You showed the NASA project, actually, that was one I was involved in.
Yeah.
Do you know who did the rendering for that drawing?
For the NASA? Actually not.
Okay.
Who did that?
This was 2012, Benas Farahi. And 2007.
That was with Xavier, right? Xavier de Castellano.
No. It was with Berojos Neves.
Yeah.
So 2012, we published a book on 3D printed body architecture, which is to say, don't think of architecture just in terms of the building. The concept, and Paolo Antonelli wrote an article, an interview in that volume, AD. Architecture is just part of a broader spectrum of design. You also can do other things as well and call that architecture. Secondly, I wanted to point out that 2012, she's doing that. 2024, she is a professor at MIT Media Lab. Where are you guys going to be? She did that when she was a student like you. Where are you guys going to be in 12 years' time? So what you've got to design is not just architecture limited to buildings, but your own career. And I think we've seen today an incredible design for Nagami, which is not just about producing beautiful things, but working out, using an architectural mind to understand systems and understand how to make it work. I sort of thank Manuel for an incredibly invigorating lecture. That really was a shot in the arm. Fantastic, wonderful example. Take that with you and think about what you can do with your own life. So thank you, Manuel.
Thank you.
And thank you, Daniel from Reekolect, for the sponsoring of this. The next session we have is Wan Yu-he, who was a student here on the Doctor of Design program until December, and is one of the world leaders in terms of producing AI software for architecture. That's going to be on the 18th of March. And at the end, we're going to have somebody in December of later this year, we're going to have someone who was shown here today, Patrick Schumacher, on the video today. So I look forward to the rest of the sessions, but thank you so much. Manuel.
Thank you. Thank you so much. Thanks.